Hi, good morning to all. I'm Shiraz with you. Today we discuss about efficient computation of a 2n point DFT of a real sequence using a single n point DFT. That means we consider a 2n point sequence. That means a sequence have a length of 2n. Okay, we consider a sequence g of n. It is a 2n point sequence. That means its length is 2n. Okay, and the another property is that it is a real sequence. It is a real number sequence. G of n is a real number sequence and the length is 2n. Okay, here its DFT is computed using a single n point DFT. Okay, G of n is a 2n point sequence and its DFT is computed using a single n point DFT. What is the reason why we go for n point DFT? Okay, we know that as the length increasing, the total number of multiplication and total number of addition is also increased. Okay, whether in using equation or FFT algorithm, as the number of sequence increases, that means the length of the sequence increases, its complexity also increases based on number of multiplication and addition operation. Okay, so here we take a G of n, that is the input sequence. Okay, its DFT is computed using a single n point DFT, but the sequence must be a real sequence. Okay, that means if n is equal to 8 means 2n is equal to 16. Length of the sequence will be 16. Here we consider n is equal to 8, that means 2n is equal to 16. That means the G of n have a length 16. Here G of n is a 16 point DFT sequence, 16 point sequence. So G of 0 to G of 50. These are real number system, real number sequence. Okay, so our aim is to find the DFT of this G of n. We want to find the DFT of this 2n point sequence. Okay, that means the DFT of a G of n is taken as G of k. We want to find the value of G of k. Okay, first of all, we split G of n into two sequence x1 of n and x2 of n. First we split G of n into two sequence x1 of n and x2 of n. x1 of n is the even indexed sequence of G of n. x1 of n is the even indexed sequence of G of n. That means G of 0, G of 2, G of 14. Okay, that is the even indexed. These are even indexed and in general it can be denoted as G of 2n. Then next sequence x2 of n, it must be odd indexed sequence, that is G of 1, G of 3, G of till G of 15. It is a odd indexed sequence, so in general it can be denoted as G of 2n plus 1. Okay, that means G of n, its length is 2n. It is split into odd sequence and even sequence. This is the even sequence and this is the odd sequence. So what will be the length of x1 of n and x2 of n? G of n have a length 2n and we take the even indexed values. So x1 of n have a length capital N only. x2 of n also have a length capital N. Okay, G of n is 2n but x1 of n and x2 of n have a length capital N. Okay, then we define a new sequence x of n using x1 of n and x2 of n in such a manner that x of n is equal to x1 of n plus j into x2 of n. That means x of n is a complex sequence. Okay, you must notice that G of n is a real sequence. We split G of n into two sequence x1 of n and x2 of n. So it have a length capital N only. Okay, then we combine x1 of n and x2 of n in such a manner that x1 of n plus j into x2 of n. That means x of n is a complex valued sequence and its length is capital N only. Okay, so its length is capital N only. Then we can compute the DFT of x of n, that is denoted by x of k. Okay, here G of n have a length 2n, that is equal to 16. We take half of the sequence. That means x1 of n and x2 of n have the length capital N. So using endpoint DFT, you can calculate the value of x of k. Okay, x of n have a length capital N only. So using endpoint DFT. Okay, that means using DIT FFT algorithm or DIF FFT algorithm or direct method. Okay, you can compute the value of x of k. It is required only endpoint DFT algorithm. Okay, is the endpoint DFT sequence x of k. So once x of k is computed, we can find the relation between x1 of k and x2 of k. Okay, what is the relation between x1 of k and x2 of k with x of k? We know that x1 of k is the DFT of x1 of n. Okay, it is the DFT of x1 of n. x2 of k is the DFT of x2 of n. Okay, what is the relation between x1 of k, x2 of k and the x of k? Okay, so we can check that. We know that x of n is equal to x1 of n plus j into x2 of n. Okay, we take the conjugate on both sides. So you got x conjugate of n is equal to x1 of n minus j into x2 of n. Okay, here due to conjugate, here plus j, it is changes to minus j. And here left hand side, x of n become x conjugate of n. Okay, using from 1 and 2, you will get the value of x1 of n and x2 of n like this. x1 of n is equal to x of n plus x conjugate of n divided by 2, and x2 of n is equal to x of n minus x conjugate of n divided by 2j. Okay, x1 of n is equal to x of n plus x conjugate of n divided by 2, and x2 of n is equal to x of n minus x conjugate of n divided by 2j using this equation 1 and 2. Okay, then what is x1 of k? We know that x1 of k is the DFT of x1 of n. Okay, x1 of k is the DFT of x1 of n. We know that it is the DFT of x1 of n. Okay, so what is x1 of k? From the equation 3, here we left hand side we take the DFT. Okay, using, if we take the DFT of this one, x of n, what is the DFT of x of n? That is x of k. Plus, what is the DFT of x conjugate of n? Using complex conjugate property, we know that it is x conjugate of minus k. Okay, using conjugate property, x conjugate of DFT of x conjugate of n is x conjugate of minus k divided by 2. That is the DFT of x1 of n. That is x1 of k. Then DFT of x2 of n is denoted by x2 of k. Okay, DFT of x2 of n. Okay, DFT of x2 of n is denoted by x2 of k. Here we take the DFT of this right hand side. That is x of n. DFT of x of n is x of k minus x conjugate of n. Its DFT is x conjugate of minus k divided by 2j. Okay, so the relation between x1 of k and x2 of k, the relation of x1 of k and x2 of k with x of k is derived here. So using x of k, you can compute x1 of k and x2 of k. Okay, that equation is shown here. Okay, x1 of k and x2 of k. So till now we are doing this much process. So we have a sequence g of n, its length is 2n, and we split into two sequences x1 of n and x2 of n. It have a length capital N. x1 of n is the even indexed sequence and x2 of n is the odd indexed sequence of g of n. Then we combine x1 of n and x2 of n in such a manner that x of n is equal to x1 of n plus j into x2 of n. Its length is capital N only. So using endpoint DFT, you can compute the value of x of k. Okay, here g of n, in this example, take g of n is a 16-point sequence. Okay, we divide into 8. So x of n is a length 8. So we take the DFT, that means x of k have a length 8. Then from x of k, you can compute the value of x1 of k and x2 of k. From x of k, you can compute the value of x1 of k and x2 of k. Okay, what the process is required? Only normal addition, and you can compute x conjugate of minus k. If we know the value of x of k, we can easily compute x conjugate of minus k. Here conjugate and reversal operation only. Okay, so from x of k, you can easily compute x conjugate of k. Then from that, you can compute the value of x1 of k and x2 of k. Okay, if we know x of k, it is an 8-point DFT. Using n-point DFT, you compute x of k. From the x of k, you can compute x1 of k and x2 of k. But our aim is to compute the value of g of k. Okay, g of k have a length 2n. Okay, g of k is the DFT of g of n. Okay, we want to compute g of k. It have a length 2n. So how we can represent g of k in terms of x1 of k and x2 of k. Okay, next we look how we can represent g of k in terms of x1 of k and x2 of k. Okay, that is the next section.